Good morning, everyone. My name is Xiang, and today I will present my project titled AI Car Plate Recognition System. So this project applies the communication system concept to capture, transmit, process, and recover vehicle information. So the main purpose to recognize a vehicle's license plate automatically and use the recovered information to support and assess control decision. An AI recognition system uses computer vision and deep learning to extract the useful information from the images or the videos. From a communication engineering perspective, the vehicle plate is the information source, while the camera acts as the input in transducer. It converts the reflected light into a digital image signal. So the image is then encoded, transmitted through a communication channel, and processed at the receiver. So finally, the visual information is decoded into the readable plate characters. Therefore, this project is not only an AI application, it's also a complete digital communication system involving a signal acquisition, source encoding, wireless transmission, decoding, and feedback. So here we have the technical system diagram. So the diagram shows the complete operation of the system. So first, the camera will capture a real-time image of the vehicle. The Raspberry Pi will receive the camera frame, select an image, and compress it before the transmission. So the compressed image is then sent through a Wi-Fi using a HTTP on the laptop. In communication terms, the Raspberry Pi acts as the transmitter, while the Wi-Fi acts as the communication channel, and the laptop acts as a receiver. So the laptop will process the image, localize the license plate, and convert the characters into the text. So the recognized plate is compared with the database to produce an assess decision. If the result is unclear, the feedback is then sent to the Raspberry Pi to capture another image. So this feedback process is similar to the retransmission in a communication system. Here we have the hardware configuration. So the main hardware consists of a Logitech webcam, a Raspberry Pi 5, a laptop, Wi-Fi hotspot, and also the gate controller. So the webcam is the transducer that converts the optical information into the digital image samples, while the Raspberry Pi controls the image acquisition and prepare the image for the transmission. Since the Raspberry Pi has a limited processing capability, so the intensive image processing is assigned to the laptop. So both devices communicate through a local Wi-Fi network. So this creates an edge computing architecture because the processing server is located close to the image source. So the final decision is returned to the Raspberry Pi, which can send a control signal to the gate controller. So here the camera continuously captures the image frame at the selected resolution. Higher resolution provide more plate detail, but it also produces a large amount of data. So the Raspberry Pi selects a suitable frame and compress it into the JPEG format. So JPEG format is a form of source encoding. It removes the visual redundancy and reduces the file size, resulting in a lower bandwidth usage and shorter transmission time. However, the excessive compression can remove the important character details. So the JPEG image is transmitted through a Wi-Fi using a HTTP POST request. After processing, the laptop will return the plate result in the JSON format. So therefore, the system uses the bidirectional communication. Image data travels to the laptop, while the recognition information travels back to the Raspberry Pi. In image processing, after the image is received, it passes through several image processing stage. First, the image will resize to provide a consistent input resolution. The plate region is then detected and cropped so that unnecessary background information is removed. Next, the plate image is converted into the grayscale, which contrast enhancement and sharpening make the character boundaries clearer, while noise reduction removes the unwanted image variations. So thresholding can then separate the character from the plate background. In communications engineering, these processing methods improve the quality of the useful signals. Cropping removes the background noise, while the contrast enhancement improves the effective signal to noise ratio before the decoding. The plate recognition process begins with the plat localization. The detection stage identifies the plat and returns the bounding box coordinates. These coordinates will define the position, width, and height of the useful plat region. The crop plat is then passed to character recognition. The recognition process will analyze the visual features such as the edge, the sharps, and the character patterns and convert them into the alphanumeric text. After recognition, the space and invalid symbols are removed. The result is also checked against the Malaysian plate number formats. From a communication perspective, the plate detection isolate the useful signal, character recognition act as an intelligent decoder, and format checking act as an error detection mechanism. So once the plate number is recovered, it is sent to the registration database. The database will search for an active matching record and check whether the registration is approved or still valid. If the plat belongs to an approved resident or valid visitor, the system will produce an access granted control signal and opens the gate. If the plat is unknown, the system will continue to visitor verification and record the attempts. So the recognized plat is then recover the message, while the database will validate whether the message represent an authorized vehicle or not. So the final access result is transmitted back as a control command. If the recognition is uncertain, the system will request another image instead of immediately making an incorrect decision. For the community, this system can reduce the vehicle waiting time and the workload of security personnel. Automatic recognition also improves the security because every vehicle entry attempt can be stored with a timestamp and recognition result. For the country, these projects support smart city development and intelligent transportation systems. Similar technology can be applied to residential entrance, the university campus, toll collection, parking management, and the traffic monitoring. So it also encouraged local development of AI, embedded system, and communication technology. So a locally developed system can be adapted to Malaysian platforms and operating conditions, reducing the dependence on imported solutions. This is the hardware prototype developed to demonstrate the proposed system. So the camera, the webcam will be capture the vehicle image and send the frame to the Raspberry Pi to the USB. So the Raspberry Pi will display the shock interface and send selected image to the laptop through the Wi-Fi. The laptop runs the processing server and returns the recognized plate information. The Raspberry Pi is then display the result and perform the required access control action. So this prototype demonstrates the complete communication chain like optical signal acquisition, digital sampling, image compression, wireless transmission, receiver processing, information decoding, database verification, and output control.